All right. So today we have our monthly visit at recent news in tech, AI, data, and whatever else that Paco, Nathan, and I dream up of. So again, our monthly guest here is Paco Nathan, founder of Derwin, but also now principal developer relations engineer at Sensing, where he works on graph AI and graph intelligence. So Paco, welcome to our monthly installment of this podcast.
Thank you, Ben. So glad to be here.
All right, I guess I'll start. I just came from the Race Summit yesterday, so we're recording this early October, and I have a lot to say about the Race Summit. So generally, incredible conference in terms of sold out, a lot of really new users and applications and use cases of Ray. And but what I'll do for my first item is highlight what I think is one of the more interesting announcements at the Ray Summit, which is this thing they call the Ray compiled graphs. So the challenge they're trying to address is how do you efficiently build and execute workloads that require coordination across multiple GPUs, right? So you can imagine GPUs might sit in the same node, but maybe they don't, right? So, and maybe the GPUs are non-homogeneous. So maybe you're using a mix of NVIDIA, AMD, Intel GPUs, and so on, right? So this is particularly important for large models that cannot fit on a single device. So think of LLMs or any kind of frontier models, right? So obviously for people who are either doing AI inference or AI training, this is going to be something that they come across quite regularly on a frequent basis, right? So manually managing and coordinating this on your own, I guess you can do that. But as Paco will attest, this is a royal pain in the you know where.
Yes.
And so I guess people might say, why not just use the existing Raycore API? You can do that, but bear in mind that that has limitations introduced by, dynamic RPC calls, right? And memory allocation. So long story short, they came up with the solution, the what they call the Ray compiled graph, which is a much more direct uh, direct attack, a direct solution to this problem, right? So again, another solution that people might bring up is, don't the GPU providers have their own communication libraries? For example, NVIDIA has Nickel. That's true, but it still requires manual synchronization management and doesn't have the higher level abstractions that probably developers will need. And also it's NVIDIA focus, right? So the Ray compiled graph is a way for you to efficiently build and execute workloads across multiple GPUs, right? So you can represent your workloads as directed acyclic graphs with explicit data dependency. So for people who use Ray, how does this impact me? So it turns out this already is in Ray Core, but it's an alpha or preview. And also it doesn't, if you're a Ray developer and all you want to do is use Ray Core, you can use Ray Core. So in other words, this is kind of made available to people who need this kind of capability. So people who are probably in charge of training or inference at large scale, right? So some of the early features already, so they already integrate with existing libraries like PyTorch and NVIDIA's Nickel library. So they support complex parallelism patterns such as tensor and pipeline parallelism. And it's designed to be pluggable and hardware agnostic. So it's a bit geeky, but I think that this will have kind of solidify Ray's kind of position as kind of that core foundational layer that I guess at least the conference kind of reinforced. Actually, I mean, you can see the number of people building on top of Ray. And Paco, I was talking to many of our mutual friends at the conference about this, right? So if I were in a position where I need to do a lot of things at scale and maybe even contemplate building my own custom AI platform, what are my alternatives? I guess
Mhm.
Kubernetes, but I mean, from scratch, that would be a maybe too low level, right? So, in fact, what I heard at the conference is a lot of people are bypassing Kubernetes altogether and just going
Yay! Yay!
going Ray directly, right? And yeah, and so then that's why you saw a lot of people at the conference. Paco is throwing up confetti for our video, for our audio listeners. But yeah, at the conference you can see kind of the many different companies from many different industries just kind of coalescing Ray as that core foundation layer for uh, their AI workloads. And I'll have more to say with my next item will also be a couple of things I saw at the conference. But yeah, there it is. Item number one from Ben is Ray compiled graphs.
Interesting. Oh, so I'm so glad to be hearing all about this here. I tried to look for where it might be in the docs just yet. I don't think it's really quite out there yet. But if you look at Alpha, you can find more. I'm really curious about memory scheduling. That's the first thing. Is just are they? It sounds like they're paying attention to memory scaling, or sorry, memory scheduling in heterogeneous clusters. So I've got different kinds of GPUs, possibly from different vendors. I'm not having to play the game of swapping back and forth between CPU memory and GPU memory. I'm hoping that that's like toward the top of the priority list.
So all I have to say there is, these people are systems people.
Yeah, exactly. This is what we go after.
Yeah, yeah.
Well, and
By the
the
way,
other,
I did interview one of the leads of Ray compiled graph, Stephanie Wang, who is
oh,
one of
okay,
the co-creators of Ray, founding engineer at Anyscale, and now assistant professor at the University of Washington. So,
yeah,
and by the time this comes out, actually, I would have written something in my newsletter about Ray compiled graphs. So I'll link to that in
okay.
the episode notes. Yeah.
Fantastic. Looking forward to that. Yeah, I mean, Kubernetes just doesn't have the fine grain control of scheduling. So trying to build from scratch, starting from Kubernetes, yeah, good luck. Let me know how that works out. So glad to hear about this.
And on to you, Paco, your first item.
Alrighty, first item. Well, I think we should talk about SB 1047 because
Okay.
this news has just come out within the past few days when we're recording this on October
Would
3rd.
you, I would label it as fantastic news.
Yes. Yeah. Where's the emoji reaction to throw a party again? Send with effect. There we go.
So,
Um,
so first of all,
so
Paco, before you continue, so as some listeners may not know, we had kind of quote unquote debate at the AI conference between Ion Stoica and the lead author of SP 1047, Scott Wiener. And I was
yeah.
too busy running around in the back. So Paco, what were your impressions of that debate? Winners, losers, or whatever
I,
observation?
I mean, my biggest two impressions were I thought that they both brought up a lot of good arguments, although I thought that Jan made a much more compelling point, even though he was only allotted a fraction of the time that Wiener was allotted. So, I mean, I think that kind of tells you there was some potential. I'd say the moderator definitely had a viewpoint. Um, and I tried to talk with the moderator afterwards. Didn't go very well. I think I said hi to Wiener, but definitely said hi to Jan afterwards. And he seemed to be in pretty good spirits. I imagine that's very daunting to be debating a state senator on stage live.
By the way, all I did with this SB 1047 news was read the headline that the governor vetoed it. But is there anything else beyond the headline?
Yeah, yeah, definitely. I mean, NPR carried an interesting story. I mean, a lot of people have been covering this, and so kind of the top line on this is, if you listen to Wiener, basically he's saying put my put my law into action. It'll be California law. This absolutely has to happen. And gosh, maybe we'll make it federal law, but it absolutely has to happen now, or else the sky will fall. Um, and the reality is that Newsom signed 17 different bills about the deployment and regulation of Gen AI technology during the month of September 2024. He vetoed the SB 1047 bill by Scott Wiener, and he cited a few things. There's a couple of points here where he's saying that basically it just wasn't clear. I mean, it's great points. I agree with Scott Wiener on many points of principle. It's just the way that it was trying to establish policy was saying we have this threshold of like number of parameters, and we're going to review it in a couple of years. And it was quirky. It was weird. It was a very awkward approach to policy that didn't really seem to be informed by like what are the classes of risk of the applications? It's really not even looking at risk, it's looking upstream at the model providers. And so there are just so many things wrong with it. And Newsom, if you look, I'll link in the notes, but there's the announcement from Newsom. He's basically saying this isn't good enough. I've actually got a link to his response
So
in here.
my main question to
The
you
veto
is,
message itself.
will the proponents of SB 1047, did they say they'll try again?
Yeah. I mean, he will. I think it's really important for people to read the actual letter from the governor to the California State Senate about why he's returning it. He talks about any framework effectively regulating AI needs to keep pace with the technology itself. There's just so many problematic things in this legislation, but yet at the same time, he's actually enacted multiple other bills toward
That are
this.
more targeted, right?
Yeah, that make a lot more sense. And he's making the point we're building up case law and legislation, moving toward let's take a look at this at a national level because that's really what makes sense. And then Wiener fired back with this like unhinged response on X, on Twitter, about again, if you don't do exactly what I say, the sky's going to fall. So it sounds like Wiener's going to mount efforts to try to revisit this, although other people are revisiting it. And I mean, one of the things that Newsom said was that he announced that Dr. Feifei Li, called the godmother of AI, also Tino Cuellar from National Academy of Sciences and Jennifer Tourches, let's see, out of Berkeley. They'll help lead California's effort to develop responsible guardrails for deployment of Gen AI. State agencies have been ordered to expand their assessment of risk from potential catastrophic events. I think the thing there is like we already have a state government. We already have ways to control things. We have laws regarding criminal behavior. Let's be cognizant of what's happening with technology and adapt, as opposed to just saying, oh, by the way, there's a new little component of technology, and we're going to create this whole body just for that one component and make it act like the DMV. So I think that it's looking good for California to respond in a very proactive way about this, and hopefully, as usual, set the pace for a lot of legislative initiatives that percolate throughout the United States. California is usually a test bed for a lot of new legislation, so it seems like the right thing happened.
Yeah, I'll take the win for now, and I won't say more. And I'm sure the proponents will try again, and we'll revisit this issue then. All right, my next item is will culminate in what I consider the best example of GraphRag in production today. But I wrote a newsletter with subject structure is all you need. And part of that came from the observation that GraphRag is great, but a lot of people are getting intimidated by the fact of creating the knowledge graph. And so maybe they give up before they start because maybe they find that task is both easy to do but easy to do inaccurately, as Paco will attest. Create a knowledge graph is easy, but it's also the reason it's easy is because your knowledge graph is probably low quality if you're just prompting your way to a knowledge graph, right?
Absolutely.
So my observation is actually the main thing that people should take away from from GraphRag is that structure is useful. And so if you harken back to the early days of RAG, people already knew that metadata was useful, right? So you can use metadata to filter. For example, you want only the last month's items, right? So things like that. So as long as you have metadata. So if don't get too intimidated, extract the structure that you can. So I cited a couple of examples there, for example, from Timescale, where they used uh, their example had to do with GitHub repos. So they also mined other metadata from the GitHub repos, put that in a relational database, and then used the combination of RAG and relational queries to improve the search results that you then feed to your LLMs, right? So, and then there's also an open source project called Sycamore, built on Ray, coincidentally, because they need it for scaling. So what Sycamore does is it takes advantage of the structure in your unstructured text. So imagine you have PDF files that have tables or chapters or abstracts, section headings, and things like that. So they organize all of that in a hierarchical graph, which might better inform your retrieval. And again, these two examples show you that short of an actual knowledge graph, maybe you're leaving a lot of structure on the table if you don't take advantage of it. And then finally, I culminate by showing what I consider the most interesting, at least to me, example of graph frag to date for two reasons. One, the graphs came from structured data. So in this case, the example comes from Metaphor, a company advice, which you can find at metaphor.io. So the end application is basically knowledge management. So think data governance, knowledge discovery, searching through your data sets and so on and so forth. So the first graph they build is what they call the technical graph. So they go through your data warehouses, databases, systems, and extract all the metadata they can, right? So the schema, the relationships, all of that. So the usage patterns and all of that, the queries people use. And then the second graph they build is basically they take that graph and maybe regular business users won't understand the terminology in their graph. So they map that into business friendly terms, right? So maybe the column names were designed by data warehouse nerds who had no regard for interpretability of column names, you know. And then finally, the one thing that I think that they really opened my eyes to is the social nature of our data, right? So in this case, data itself is you can have many data sets in a company, but by studying the usage patterns, the roles of people, who's reading what reports, who's the influential analyst, and so on and so forth, you can actually extract a lot of information about data itself that may not be apparent just from looking at the underlying systems, right? So you might actually need to. So basically, you're adding contextual information to your data. So now what they have is three knowledge graphs: technical, business, social. And then that's what they then use to power their graph rag. So I find it, I consider this the most interesting graph rag use case in production for two reasons. One is they actually use mainly structured data, which a lot of people forget, right? So don't don't assume that the only way to construct a knowledge graph is through all this unstructured text just because unstructured text is sexy now. And then secondly, maybe you have multiple views of your graph, that maybe there's not one universal graph. Maybe there's different perspectives that you can apply to your retrieval process that might help inform it. So there you go. So I would consider this basically the item I would entitle structure is all you need, but basically the lesson here is don't leave structure on the table. It might help inform your retrieval process, which might enrich your RAG, short of going into graph RAG.
Oh, well said. It really strikes me if a person was around when recommender systems were kind of a novel thing and sort of emerging, and there were practices getting reported, and it really unfolded into, enormous practices. Like you look at what Walmart does with Rexis. Um, if you saw that trajectory, what's happening with RAG and the narratives about RAG and all about how this is unfolding is such a parallel thing. I mean, it's like the more that you can leverage structure, obviously, the more that you can get better recommendations. And this had a lot of impact on social media and e-commerce, et cetera. And we're seeing a very similar kind of reapplication of these ideas and processes in RAG. I will say that a lot of the early RAG tutorials were kind of toys. It's good to get the ball rolling, but a lot of, like you say, a lot of what was being represented is like just using LLM to generate a graph. It works in the trivial case, and it's great if you're doing a medium article
Or,
that's 3 minutes long.
like you said, low stakes applications where maybe you can afford to have mistakes. But by the way, as
Yeah,
you were talking, it just occurred to me, right, that what you're working on now, entity extraction and entity resolution, I mean, it's fundamental to everything I just said, right? So extract
yeah,
structure
it
from your
is.
data, but
Yeah.
make sure it's correct at some level, right?
I mean, the TLDR is like, you probably, whether you know it or recognize it or not, you probably have some schema that your organization is working with. There's some business process, there are definitions. You're beholden to certain compliance, regulatory framework, whatever. There's some kind of schema, taxonomy, ontology, control vocabulary, some structure there, but that's abstract. And then you've got some structured data, which you use and you curate, and yeah, exactly, use entity resolution, merge it. And from that, you get the backbone that then you can use entity linking to bring in your unstructured data. So that's the steps of building a graph that are sane and allow for human feedback and audits at every stage, as opposed to just like a black box. Um,
What about
so
Paco, this notion that they have where actually you might be leaving a lot on the table if you don't pay attention to the social nature of these things, right?
well, I
So
mean, yeah, I saw the
so
breakdown.
so certain analysts might be much more well regarded in your organization. Certain reports might
Yeah,
be better used, or certain,
yeah.
you might have multiple tables that purportedly compute revenue or churn, but one is much more widely used by the most regarded analysts, right? So
Well, I mean, there's a couple of things. I mean, one is again, I'll link to some talks I've given in this area and also some open source if you want to get your hands on. But the word graph and graph rag, I've counted at least a dozen different conflicting usages of the
yeah,
word
yeah. For
graph.
me, graph rag just means rag with some knowledge graph or some graph.
But
Uh,
there's probably three or four or five or six. Yeah,
I
exactly.
mean, look at the post that I wrote with Prashant. I think we stopped at
Yeah,
five, but
yeah.
you
So,
can keep going, right? So
yeah, and the TLDR there is like, if you really are in a large organization, you're a government agency or enterprise, you're working, with your partner ecosystem, even if you're a startup. If you're in a large organization, really this kind of domain perspective, like domain driven design used to be the buzzword, but look at the domains. Like people in HR use the word consideration very differently than people doing contract law. And if you don't understand those distinctions, you'll get tripped up in a huge way. People use the word customer differently in the different domains within your organization. And if you don't understand that, believe me, you're going to make huge mistakes, either legally or financially. So looking at your different domains and modeling those as graphs is probably, that's the best learning that came out of K-First IAC this year at Stanford. We just heard this from so many different teams that are working on this in production, is look at the domains. So there probably are multiple graphs you'll have. You might say that this is a social graph or this is a domain or whatever. Look at your domains and see how they blend together for a given use case. That's probably the biggest learning. And I'll also say, like over the past few weeks, I'm not gonna disclose anything or name any names, but I've been talking with lots of banks, insurance, as well as government agencies, tax agencies, various kinds of investigations who are doing this, who are doing graph ragging production, and hearing about what their concerns are. I think that you probably also want to think about graphs at a couple few different levels of detail. Like there might be something at a very low level that's fine grained, used to kind of organize and keep track of provenance, like you're saying, like what metaphor's doing. But then you go up to a higher level of abstraction, and that's maybe where you actually start applying some graph algorithms. So understand that things aren't flat, they aren't
yeah, yeah.
monolithic.
That's why I found their example interesting in that. they're not confined to unstructured data, but they also emphasize there's no single graph, right? So,
Ye- Yeah, I
and,
linked in here a tutorial where we're showing how to bridge between structured and unstructured because we deal mostly with structured,
mhm.
but realistically, 80% of the data is unstructured. So the thing between that is entity linkers, and I'll throw out a teaser. By the time that this episode comes out, we'll probably have published a new uh, open source project about entity linking that's being tuned to be contextualized
So
based
by
off
the
of
way, so
generalization.
the thing that I keep going back to the metaphor example is it's in production, right? So it's not
Yeah,
it's a real thing. And on the social thing, I just thinking about this earlier this week or last week actually. Other aspects of your of your organization and data sets might have that social component. So imagine
yeah,
you have an experimentation platform where many people in your organization are running experiments, right? So and maybe there's duplicate experiments being run that have been run in the past. I mean, it'll be nice if you had some context to, hey, Paco is really the rock star for running this type of experiment. So if you
well,
can somehow, if somehow your system also allows for some kind of annotation and data annotations on the part of users, right? So, oh, Paco, I looked at Paco's table for this for
yeah,
revenue. It's the best. You folks should all use this, right? So there might be some UX elements to
yeah.
your systems that might allow people to annotate to help themselves discover, and then furthermore later on you can leverage all of their kind of annotations, right? So
Well, in practice with in like enterprise, working with knowledge graphs in practice where that really brings a lot of return on investment is competitive analysis. So the social graph is important inside your own organization to understand who's working with whom and what's salient. It's even more important when you're trying to understand your competition because like if you're in manufacturing, you don't want to step on your competitors' patents. And patents are usually issued in the name of inventors, but it doesn't disclose who it's assigned to. So if you can develop a social graph of your competitors, you can find out, really what is this patent probably being used for, and how does that match with the academic papers and who they were co-authoring with, and then you can kind of zero in on like, oh, okay, let's stay away from that one. That's going to get us in trouble legally.
and so that's my second item. On to you, Paco.
Okay. Uh, yeah. So I think the other thing we should really talk about would be Llama 3.2. So Llama 3.2 and lots of multimodal goodness. Uh, so if you haven't seen, Meta made the announcement last week on the September 24th about multimodal Llama 3.2. There's the 11 billion and 90 billion vision models, and these are drop-in replacements for the corresponding models that were focused just on text. So now you can start to do something natively with images, computer vision, etc., alongside what you're doing with text. There are the lightweight text-only models out of the Llama 3.2 line now, the 1B and the 3B, and they fit onto mobile devices, they fit onto Edge. I think it's really going to open up. One of the things that I heard, you know, approximately, we're talking now on October 3rd. So approximately a month ago, we had this period of we had IAC conference at Stanford, and then we had the AI Alliance leadership dinner. People from all over the world flew in. Then we had the AI conference in San Francisco. We had a couple of weeks there with a lot of events going on, and I kept hearing over and over how much people are leveraging the Llama 3x line for production work. And with 3.2, we heard a little bit about this at the AI Alliance leadership dinner, and now it just came out last week. Um, I think that this is a huge benefit. Meta is working closely with AWS and Databricks and AMD, et cetera, making models available downstream to enterprise clients. There are downloads that are on Hugging Face and llama.com. And also to put this in perspective, it's only been like a year and a half since the initial Llama release, which I learned I hadn't known before, but it was actually the team that did the initial Llama model was also the team that went and did Mistral. I didn't know that before.
Yeah,
Um,
they were researchers at FAIR.
Yeah, and so there's been like a 10x growth during 2024 for Llama. It's really compelling. These models are now competitive. The 3.2 models are competitive with the corresponding leaders amongst foundation models, like Claude 3 Haiku, GPT 4.0, like on image recognition, visual understanding tasks, and stuff like that. So I think that this is a really big boost. A lot of the buzz that I've heard over the past several weeks, like again, coming off these conferences, I kept hearing multimodal over and over and over again about the applications, even just like for embedding models. Like having good multimodal embedding models will get you pretty far at a very cost-effective way. So Llama 3.2, this is really exciting to see. I was trying to see if yeah, the to quote them, the 11B and 90B models can bridge the gap between vision and language by extracting details from an image, understanding the scene, crafting a sentence or two that could be used as an image caption to help tell the story. And if you are working in graphs, also kind of a teaser for something coming out, think about your graph being multimodal and having these different kind of sources in there, but then think about how you can do community summarization, like you have an area of the graph where you've maybe got some images, but also some ontology, but also some structured data linked in. How can you take that particular little area and summarize it in a text or a diagram, and then use that as, in your vector database? That's an interesting idea. Hopefully we'll see more of that. So I think that Meta has really helped everybody with a big boost, and there's more coming.
So yeah, so I'm still a bit worried that we're dependent on Meta and they keep calling their models open source when they're not. But that's fine. That's a small quibble. So at this point, I would say I have access to over 30 models. OpenAI has multiple models. Gemini has multiple models. Llama and Anthropic have multiple models. Actually, people are sleeping on Alibaba's Quen model, which is actually quite
Mhm.
good, probably
Yeah.
close to Llama, which,
Microsoft models also.
which is impressive given the export control. So I would say
Mm.
in the open weights models, unfortunately, we have two suppliers, Meta, which, God bless them. Hopefully they won't go down the enshittification path when it comes to
Yeah,
when it comes to models, but and Quinn. I think Mistral is a
yeah.
bit of a I don't know what's going to happen to Mistral
Mm.
because their largest models are not even open, and then their smaller
Right.
models, I'm not sure. You have Llama and you have Gemma, right? So
Yeah.
which are open. So maybe so I'm actually also a big fan of Llama, but I use the Gemini, Anthropic, and OpenAI as well. Maybe Google should consider maybe even ratcheting up Gemma. Gemma is like the
Yeah.
open source,
Yeah. The open side.
open
Open.
weights,
Wait.
open weights
Yeah.
Gemini, right? So maybe they can ratchet that up, and then maybe we have two suppliers of open weights models, right? So,
Yeah.
but for now, we are in a position where we have Metas being at least in the West, right? So I'm not counting Alibaba Quen, even though that's a pretty good model. And by the way, so people are also talking about the OpenAI O1 preview, which was released the day after the conference,
The conference. Yeah.
which
I
was
noticed
because I
that.
asked Mark Chen, so when's the next model, man? And he just smiled at me, right? So, and then 2 days later, it released. So, O1 is, pretty. It's an interesting model. I think it's pretty good, but I don't know if it's. I don't see differentiation between the large model providers. In other words, okay, so they're doing this now, a little bit more reasoning, but I don't know that that's something that Llama or Gemini can't add in a month or two, or Anthropic, right? It's just that OpenAI seems to always want to be the first to do something, but doesn't mean that they will remain the only ones capable of doing something. So the
Yeah.
lesson for listeners is assume lack of differentiation between these models. So architect your system so that you are not uh, dependent on one model provider, right? So always architect your system so that you can use many different models and even fine tune many different models, right? So
Yeah.
I just don't see there's going to be much differentiation. I mean, most of the teams building these models are in the Bay Area and they all go to the same parties. They talk to each other. So even though no one's publishing papers, I just don't see and they go back and they go migrate between companies. So I don't,
Yeah.
maybe there'll be differentiation, right? So there's an MIT model that's got released, the Liquid AI, that's non-transformer based, but then you look at the comments and the people trying it out, and it's not it's obviously they when everyone releases they show all the benchmark results and how they're graded benchmarks, but the proof is in the pudding. As Paco pointed out, the reason people are excited about Llama is because they're using it and they're seeing that it
Yeah.
works for them, right? So with this new non-transformer based model, it's not open, so you're gonna have to convince
Yeah.
people to try something completely different. And for you to convince them, they have to use it on their own data and they have to get blown away by it. Because why would they drop, if the advantage over Llama is incremental, why would they drop Llama over a closed model that they don't even understand how it works, right? So.
Well, I mean, perhaps another takeaway might be, I'm asking this really as a question, but maybe another takeaway might be that none of this is happening in a vacuum, referencing some of what you mentioned there. I mean, whether we're talking about legislation like, SB 1047 attempted, or looking at export controls, or looking at what's happening, positioning of Alphabet versus Microsoft versus everybody else. None of this happens in a vacuum. So, I mean, if Meta pushes something with Llama, maybe that will help shape how Google prioritizes
Yeah, that's why maybe
theirs.
they respond with Gemma. Gemma
Yeah,
being a
and
bigger model, right?
maybe it informs better policy approaches, like maybe open models versus open weights might be a matter of legislation about how they get handled or regulated. I mean, I think that, that's a takeaway too, is that there's different actors, they're bouncing off each other, although unfortunately so many of them go to the same parties and live in the same city.
And also, I think that the two main startups, OpenAI and Anthropic, right? So they are up against uh, Alphabet and Meta, who have deep pockets, who are supporting their model development with ads. So as
Yeah.
models get more expensive to build, they're going to have to raise more money at higher and higher valuations, right? Because I guess you can raise money and have a down round, but then your employees will take that as a signal that it's time to leave. So it has to keep going up constantly. But then, if there's lack of differentiation, I mean, OpenAI raised 6-7 billion yesterday, right? And then it turns out they made what 3.5 billion, but they lost 5 billion. And now models are going to get more expensive to train, and they're paying salaries at the level of Meta and Alphabet
Yeah.
to attract talent, right? And then
Yeah.
the Anthropic was also in the same boat. And then it turns out I read somewhere 85% of their revenue, Anthropic, is from Amazon Bedrock. So in a different world, if Lina Khan is not the chair of the FTC, maybe Amazon would have bought Anthropic by now, right? So
Yeah, interesting. Yeah, there's also the antitrust side of it. Yeah.
yeah, so the two leading startups, they're kind of in this arms race where things are going to get more expensive. And going back to my point about lack of differentiation, right? So they can't jack up their price, because if they do, it's not
Yeah.
like I can't use another model, right?
Yeah. Yeah.
Yeah, yeah. And so, okay, so my next item is two short ones. So I guess this is kind of my rapid round. So at the Ray Summit, two things, right? So one, vLLM, Paco. Wow. The growth in vLLM is just insane. They had a whole track about vLLM. So for people who are not familiar, vLLM is an open source library that came out of Berkeley, basically, whose mission is to be the best library for LLM inference and serving. So it's actually not just LLM. Basically, think of it as the best library for foundation or frontier model serving, open source. So many people using it. I mean, like I said, they had a whole track of not so the track wasn't not just here we are vLLM insiders and this is the latest features. No, these are actual use cases from major companies like Uber, Roblox, right? So incredible. So the growth in this library has been impressive to watch. I think if you're interested in productionizing frontier models and LLMs, this is a library you need to really pay attention to. And then secondly, Ray Data is now GA, and I used Ray Data early on. So listeners, think of Ray Data as basically unstructured data processing, especially for GPU intensive workloads. Obviously, you can do mix CPU GPU workloads, but for unstructured data, right? So if let's say you're computing, as Paco said, multimodal is big, multimodal embeddings, right? So uh, you can do that easily with Ray, and Ray Data can help you with the pre-processing before you do the embedding, right? So I don't know. I'm just making this up. So maybe you have a piece of text and then you kind of sanitize it, remove all the offensive words, then you translate, then embed, right? So those are the kinds of steps that you can imagine a library like Ray Data built specifically for unstructured data and can support GPUs will shine. And again, I mean, I was surprised actually. A lot of people already use Ray Data in a big way, major companies, right? So, and I was early on using Ray Data, but my examples were rather simple text manipulation examples. But now people are using it for multimodal data, visual data, and all sorts of data. But again, so two libraries you need to pay attention to, vLLM and Ray Data. And I guess you might ask, why not just use Spark? Well, Spark is really meant for structured data processing, and maybe it can do unstructured, but maybe it's not optimized for when you want to, for example, use GPUs, right? So, uh, and so on and so forth. So, and also the operators in Ray Data they have certain of these operators like map. So it's not a full-fledged data wrangling tool. It's more like a last mile data wrangling tool, right? So if you want, if you want something more specific, you can probably build that in Ray. You can build the logic in Ray, but just so you know, just to set expectations, the operators in Ray Data can take you far, but maybe it might not have all the functionality you need. But yeah, the impression I got from both libraries, vLLM and Ray Data, is usage, actual usage. And vLLM, also the ecosystem, the contributors, right? So they're not just from Berkeley anymore. I mean, the largest contributor of vLLM, as I mentioned at the AI conference, is Neural Magic, right?
Yeah.
So anyway,
I was impressed by how often I saw vLLM referenced at AI conference by
yeah,
so many different speakers.
yeah.
Would you say that a pattern would be maybe you would use Databricks for more of like getting your data into shape, pulling from a lot of different sources, and then, like you're saying, Ray data is more of the last mile. Like you probably
Yeah.
use one before the
Getting
other.
it right, and you know, like I said, the example I give, right? So maybe you have a bunch of text, and then you're gonna remove all of the offensive words, right? So and then you're gonna translate, and then you're gonna embed, right? So
Yeah,
that's the
yeah,
kind of
that makes sense.
scenario that so basically some sort of data pre-processing and then embedding, which is typical these days, right? So
Fantastic.
and you.
Um, Okay, a couple of rapid fire things. One is I'll point out, Gail Vorquay and
Gael
Sasha
Barraquo.
Lucioni.
Yeah, yeah.
Veracruz, yeah,
Yeah,
Veracruz.
yeah, yeah, yeah.
Sasha Lucioni and Meredith.
Scikit
Yeah,
learn.
exactly. In RIA,
Yeah,
scikit-learn,
yeah.
a lot of Jupyter, etc. So they came out with a piece called "Hype: Sustainability and the Price of Bigger is Better Paradigm in AI." It's a really good read. There's one part in there in particular that shows some diagrams. I'll have it linked, but certainly what we're seeing in natural language work. Um, there are cases like, for instance, working with Gliner, which is zero shot named any recognition, using a bidirectional transformer, you probably get a lot better results and also a lot better performance versus cost than you would if you're using an LLM. So what they're showing is, like, if you really look into the use cases, using a bigger model doesn't necessarily solve anything. Like, for instance, in medical imaging, rare diseases, if you don't have enough data, if you just extend the size of the model, you're likely to overfit as opposed to accomplishing anything. So I think it's a really good read. Makes a lot of really good points. I would paraphrase it as, researchers proclaiming that XYZ is all you need is not enough. And MIT Technology Review did a really nice article about it, why bigger is not always better in AI. So definitely check that out. Scaling laws are a thing. But when you look at a use case, it's not all about scaling laws. There are other considerations. When you start to balance out those priorities, then you get a better picture, more realistic for what you need for your applications. The second one that I'll mention, there's, going back to GraphRag, there was a paper that came out about Graph Reader. And it's a very interesting notion of looking at organizations of graphs on top of chunks, or rather making a very formal representation of a graph along with text chunks to use in RAG. And the approach was that the entities being extracted aren't necessarily the thing you're operating on. You're operating on, like, propositions, or like complete sentences would be a way to put it. And then once you put together a notebook of those, you feed that to your LLM to do a response. Tomasz Botanek did a nice implementation of this on LangChain recently. For the people who are reading and between the lines, if you have as much white hair as I do, you may recognize that most of what's being said there was said by somebody named Barbara Hayes Roth back in the 1970s and 1980s. There was a lot of work in what was called Blackboard architectures. So Hearsay 2 did a lot of breakthrough work there, starting from like 1972. And there's open source, there's the BB1 project. It's really interesting to see some of these Blackboard architectures being revisited in terms of production work now in AI, and I think a lot can be learned from that. So those are my two things. Was definitely that first paper, and then Graph Reader.
So quick comment on this, on the first paper. So I think when people say scaling laws, they actually don't mean, they may not refer to specific applications, right? So scaling laws, I think, is a term used by people building these frontier models. Think of the teams who are building the frontier models that they believe will get to AGI, right? So that's, I
Anthropic
think,
and that kind of thing.
that's, I think, the context of scaling laws. The reason is impacts us as regular developers is they build these models, the llamas, the GPTs, and so on and so forth, Gemini, Anthropic, Claude, uh, Alibaba Qwen. The reason it impacts us is they're building these models bigger and bigger because they want more and more capable models. And us as developers and users, what the way we benefit from that is maybe we get to use a slightly fine-tuned version of that model or a reduced version of that model, and so on and so forth. So it's not that they believe that every use case requires scale. It's that the most capable
Broader.
kind of AI, general purpose AI, requires scale. And unfortunately, I think that they all are operating under this assumption until further notice, until someone shows otherwise, right? But right now, the working assumption is that's what it will take to get even more and more capable models. And I've either spoken with or been in sessions with many of the people building these models, and this is the mentality that they have. And they, I mean, at least for now, until proven wrong, it seems like that's the right direction. Unfortunately, that means the number of people who can build the most capable models is going to go shrink, because it's
Yeah.
whatever cost it is now, think of it as being like 100x more in the future,
Yeah.
right? So, and then I don't know where we're going to get the freaking energy to
Yeah.
build these models, right? So, and then, okay,
Three
so
Mile Island.
imagine the models are so big, and this is where the innovation is happening. The things around vLLM and ray compiled graphs, the cleverness around inference and distillation and quantization. We have to be super clever because we cannot actually inference these big models directly, right? So routing models, anything that will lower inference costs. By the way, so that other company I advise, meaning that team, Yishai's company, right?
Oh, right. Yeah, yeah, yeah.
Which does this cutting edge, really mind-boggling real-time speech-to-speech synthesis, right? So speech in, speech out, but in real time.
Yeah.
They
Jaw
actually
dropping.
spent a lot of time on two things only, right? So making it real time and then lowering the inference cost so
Yeah.
much so that they can run on really old GPUs, right? So, and then at a fraction of the cost. So, because basically, if once they built this model and, I don't know, 10,000 call center agents are using it on a monthly basis, each one for hours,
Yeah.
you gotta really be able to do inference on the cheap. Otherwise, you're gonna break the bank, right? So, yeah.
Some
Yeah, yeah.
different
So,
views on business. Yeah.
all right. So recommendation, I have two books, one new, one old. The first one is called Unit X. It's about this unit that the late Secretary of Defense Ashton Carter set up in Silicon Valley. The idea is to help startups work more with the DoD. So it's a fascinating read, but and it's really entertaining too. But Paco, in many ways, I'm still reading the book, but in many ways, a lot of the wins is really not tech. It's about, some way they overcame the bureaucracy, you know, like,
Right.
some,
Procurement.
yeah, yeah, yeah. Some massive bill. They found one sentence in there that got them around the walls, right? And then the second book is an older book that someone just told me about. It's about the composer Bach. It's just called Bach. It's written by John Elliott Gardiner. It's actually amazing book in the sense of, it takes you back to the period when Bach was writing all this music, and the impact on current musicians, because the author is a respected musician and conductor, right? So fascinating read. So anyway, those are my recommendations.
Wonderful. I look forward to those. My recommendation, there's a article slash tutorial that came out of Linkurious recently. It's titled UBO and How the Kleptocracy Has Been Exacerbating the US Housing Crisis. And this is an application of graphs if you're interested. And also, if you happen to be a business owner in the United States, you're probably aware that if you have a corporation, you had to file UBO for
What's
potential fin
UBO?
crime. There's something called ultimate beneficial owner, where any company has to declare who actually owns controlling interest in it. So, for instance, yeah, I have a California corporation. This year, I am required to file UBO disclosure about who actually owns this company, and if I don't, there are criminal penalties. So this has gone into effect this year, and so the data is being collected. And if you look, there are people like Stephen Abbott Pugh at Open Ownership has been helping both develop the standards as well as the open data, but also a lot of the policy rollout country by country, because different countries are rolling this out at a different time, but
And
we're getting a lot more transparency.
what's the connection with the housing crisis?
So the deal is, when you look at, okay, people say, gosh, this is, this huge cost of living in New York City or Miami or San Francisco. And then you look at one of the major drivers of this is like people coming in and buying super high-end luxury condos with cash. And inevitably, a lot of those, you find out it's some company, it's some offshore company trying to find out who the actual owner is. Good luck. They subsequently as they invest together in an area like we saw in London, then they get a lot of return on investment because they will jack up the overall housing costs. The
Also,
overall,
it's like a financial trade for them.
yeah,
Yeah.
yeah, exactly. And it's a way of laundering money. And so UBO has been one of the ways that regulatory structures across the world, also counterterrorism, also sanctions compliance for oligarchs, also finance, risk analysis. Do we know who actually owns this thing, and are they connected with somebody who's doing bad things? And so the argument really is that people say, well, there's coastal elites and they live in like New York City, and it's too expensive for general people to live there. Well, actually, that's because of a lot of money laundering that has gone into places like London and New York, and especially Miami. And then you see the local political infrastructure. Also, there's a kind of cadre, there's a kind of class that rises to help bring more of this kind of money in. So I think that Linkurious did a really nice expose, if you will, there, using open data, using graph technologies, using machine learning to explore more of where and how this is happening. And the good news is that UBO laws are being enacted across the world in different countries. Some places, maybe like Malta, just kind of rolled it back and negotiated with EU in general to do more
So
audit and
the
less
so so
UBO.
the data was always there. It took a tech company like Linkurious to actually to make it useful.
No, it depends where you are. I mean, UK has had Companies House. There have been different places that had different requirements, but now there's more of a worldwide emphasis to have standardization so that we can look at offshoring networks where money laundering is basically to paraphrase,
But the question, Paco, is do the regulators have these tools?
yes, yes. And so to paraphrase, Oliver Bullough is one of the authors in this area. The money crosses the borders, but the laws don't. And so by having open transparency, open data about who owns what, and having that be a requirement if you're operating in any particular country, then you can start to put together large open data sets and basically build up network analysis graphs of where the money laundering is happening. There's a very famous case of this called the Azerbaijani
Uh,
laundromat.
I
Um,
imagine you need entity resolution to.
Absolutely. Yes,
Yeah.
yes, you do. And so yeah, full disclosure, I work with Linkurious on the entity resolution. They're great folks. Shout out to Jean Villedieu and others. But yeah, at the end of the day, a
But
lot of
also,
these
Paco,
political issues.
doesn't it require, certain jurisdictions don't want to cooperate because they want to be kind of that financial haven, right?
Yeah, but that's falling apart. And so the
But that's
irony,
fine. But that's fine because as long as the places where people want to buy housing cooperate, right? So
right,
the
right, right,
U.S.,
exactly.
UK, right there,
If
yeah.
if New York, maybe Miami doesn't cooperate as much, but New York does London? That's a question. San Francisco does. The irony though is that the more that the US steps in and says this must be regulated, we must shut down the tax havens, the more the US does that, the more that the actual tax havens shift to Nevada. So
Or
it's like
or
we
or
cracked out of the rest of the world and then it happens here.
or the trust capital now is South Dakota.
Well, yeah, exactly. I believe also Idaho and Wyoming, but exactly, some of the red states are like, hey, if you're going to shut it down outside the country, why don't we do it inside the country? So if you want to do offshore corporations anonymously, yeah, you go to South Dakota now.
So I guess for you folks in the graph world, make this data part of the tutorials you teach.
Absolutely, and in fact, that I have been. So yeah, the one of the better data sets for this is called Open Ownership, and our tutorials have been using that. Typically, when you go after investigations like this, I'll paraphrase Friedrich Lindenberg from Open Sanctions. You have three classes of data. You have you have lists of risk, and this is how banks think about it. But it's like you have some kind of watch list. So there are risks. There are people who are known bad. Don't associate with them. And then you have some kind of connective data, which is links, like open ownership. Like here's a company, here are its directors, here are its owners. And then you have event data. It's like here's a list of wire transfers. So if you happen to have, for instance, open sanctions, here's a watch list of oligarchs who are doing very illegal things, and here's the ones in Azerbaijan. And then you have open ownership that tracks who owns these shell companies they have, and then you have like OCCRP published the Azerbaijani laundromat. Basically, here's the wire transfer of where they were stealing things from their country, laundering it through Shell Corps, and then buying up condos in Manhattan. That's you can get that as basically event data.
It
So you
seems
take
like
those three together, you've got a graph.
it seems like it's a very good data set for people to really learn a lot of concepts as well. Entity resolution, data cleaning,
Graph rag.
graph rag, merging data, right? So, and
Yeah,
graph rag itself.
absolutely.
So
Yeah.
this,
Where does data governance come in? Like you're talking about with Metaphor?
so what you just described has nothing to do with the other aspect of housing, which is all these private equity firms buying housing stock across the country and renting.
I would say it's tangential because I think that there have been a lot of, again, going back to the red states, there have been a lot of like state level initiatives to sort of enable the people who are servicing the oligarchs laundering money and buying up. And along with that, that leads toward private equity doing badness on its own. So I think it's segmented, but I think that definitely those two go hand in hand.
And with that, thank you, Paco. And for our listeners, for this series, make sure you check the episode notes because basically the episode notes have many, many of the links that Paco and I use to inform this discussion.